Kevin Finch is going to kind of meld with our course and kind of, we're going to, as we say, going to collapse the production part of Kevin's course together with the content part of Studio, and this next project will be all one. So, looking at the screen, it's really important to know that in a few minutes when Kevin starts to demonstrate, that I'll just read this from the top, that there are nuances to producing these scaled artifacts that you will have to pay particularly close attention to. Last year it was an issue in the class, and we're going to do our best to front load the class this year to kind of reduce the amount of difficulty that students have with doing this. But please listen carefully to what I'm about to say, and then pay particular attention to what Kevin's going to say. So, Topo 2 Topographic Monument, the next phase of this project will involve a huge jump in scale from the architectural scale of our campus to the monumental scale of Death Valley. We will continue to construct scaled models, this time using engineering scale and working with chipboard and acrylic to further explore relationships between materiality, form, and imagined space. There will be three parts to this phase. Part 1, the tiled site model at 1 to 500. Now this is the first place where I want you to pay particular attention. When you're listening to Kevin demonstrate and working in Autocad, we will not be working at 1 to 500 in Autocad. What scale will we be working at? Dan, don't jump at all at once. Yep, because your whole education just hangs by this one answer. No pressure.
So like just talking about in AutoCAD, not in AutoCAd.
In AutoCAD.
Yeah. It's not one.
Okay.
What scale do we model all digital and three-dimensional things at in every program?
1 out of 100?
No.
We work at real scale. We work at 1 to 1 in the digital environment. Okay? And when it says tiled site model at 1 to 500, that means from that 1 to 1 data set, we will produce a 1 to 500 engineering scaled artifact, where 1 inch equals 500 feet. Okay? So, I'm looking at Kevin.
Yeah. I think it might be easier to think of it as just 500 times smaller than the original.
Exactly. Yes. So, tiled site model at 1 to 500, working with the contour map of an area around Dante's view, the entire class will work together to construct a site model of this area. Before constructing the site, each student will perform a topographic analysis, see below, of their assigned tile, which will result in line drawings from which to extract a set of lines that will be inscribed upon the constructed tiles. Part 2, site model with a monument, 1 to 200. A portion of your tile will be selected and constructed at 1 inch equals 200 feet. So that would be a larger artifact than the 1 to 500, correct? This construction will include an inserted monument represented using laser-cut acrylic sheets. Part 3, inverted space, 1 to 200. The previous model will become a base for combining slices. This will result in a new topography within which a final intervention will be inserted. What we really need to concern ourselves with right now is just this initial production of your contours. So procedure part 1, topographic analysis line drawing. You've already read the Leather Barrow article. And so I'll dispense with the reading and writing. And then preparing your drawing, I think I may hand it over to Kevin right now, who will kind of set this up for you on in a step-by-step way.
Okay. So the next section underneath that where it says preparing your drawing, all the way down to formatting drawing, these are all written instructions on how to do what I'm going to show you how to do. So really all I'm going to do is follow the directions that are already on the assignment sheet. Okay? This first part, preparing your drawing, cut out your assigned tile and trim so all lines fit within the square. I asked you to do that last week, so hopefully you have that prepared today so that you can follow along. Here is just a square. I picked a random square. I don't know which one it is. Don't ask me which one it is so you can copy exactly what I do. Irrelevant. I don't know what square it is, okay? But when you do this, you want to make sure that you have at a minimum of 2 pieces of information. One would be an elevation of one of these contours, okay? Within this particular square, there were no numbers. I didn't know what was what. So I had to copy one of the text boxes right here where it says 4800. I had to copy that over from an adjacent square so that I could tell myself that that's what this topo line's elevation is. Okay, so that's the first thing you need to know. Okay, the more the better, but you need a minimum of 1. And the next thing you need to know is in which direction the topography of your square is falling. Okay, I have a relatively simple topo here, and it's not noted on this square, but I do know that it runs from a high point over here down to a low point over here. The way that you can verify that is by continually tracing or just following visually the lines on the overall topo and seeing where the next highest or lowest elevation marker is. Okay? So you can either know one of your elevations and know which way it falls, or know 2 of your elevations and work from that. Okay? Do you know how to tell the difference whether a topography is rising or falling? I know that some of you have kind of self-contained mounds within your topo squares. Are there any questions about how to figure that out? Which way is up, which way is down?
I guess you would call them the arcs of the wavy undulations would typically go downhill.
Sort of. Sort of, yes. It has to do with the geometry of the lines themselves. If this one is 4800, okay, and these are 40-foot contours, so the next one higher is going to be 4840, okay? In terms of, if you have a more complex shape, does anyone have another one open? That's fine, don't worry about it. Within those self-contained shapes, you figure out which, you kind of just count the lines, right? So then the next one over would be that 4840 if it's going up, or 4760 if it's going down. And you, good.
I was just going to say, when Kevin refers to a self-contained line, just to restate it in a different way, he's talking about a contour that closes on itself, upon itself, as a closed figure within your kilometer square quadrant. So he's drawing one right now.
Something like that.
Now, again, one of the hardest things that we were debugging out of students' projects last term, I think two common errors are that you actually create and cut your contours and do them backwards, and you mistake the low for high. Another one is when you have a closed figure like the one Kevin's referring to, sometimes it's hard to know whether that's a valley, a depression, or a peak. So that becomes incredibly important, and the error becomes evident because we will be assembling all of these quadrants when the models are eventually built, and we'll be able to tell, number one, if your topography is backwards, because it won't match with your neighbors. And it will also become evident just by kind of looking at it, whether that valley should have been a peak.
Okay.
Questions? No?
Okay. So you'll start with this and that information in sort of available to you, okay? So the next step, finding points. Create a layer called points and set the layer color to red. I've already set up my layers, but you should know this, but to create a new layer, you click on New Layer under your Layers tab, and to change the color, you click on the color, and these would be the index colors that the assignment is referring to. If it says red, it's this red. If it's yellow, it's this yellow. If it's green, it's this green, so on and so on, okay? These are index colors. It has a lot to do with colors, line weights, fabrication, all that kind of stuff. These are the kind of standard colors being used. Okay, so we've got that layer, points, titled red. And then, okay, so moving on to this next step. Find the contour line that is 2 intervals lower than the highest point, okay? So you want to identify the highest point in your square, okay? For me, that's this little line right here, okay? What you want to do is find the elevation that's 2 contours lower than that, okay? So I just count over 2 contours, 1, 2, and I would start with this line right here. Okay. We will call this contour A, and we're going to put it on layer points. Okay, so to switch geometry from layers, you can go up to the layer properties panel, click on the drop down, and then select the layer you want it to be on. And I know that it's on the layer I want to be on because that layer has a display color of red, and that line changed red. Okay?
That was really important, everybody. That's your starting point. If you don't get that correct, the whole kind of algorithm of what's about to follow will also be erroneous.
The next part, divide it into 20 equal segments and make small marks along the polyline to make the dividing points visible. Okay? I'll show you a couple of ways of making it visible that I think might be a bit simpler. But it said to divide it into 20 equal parts. Okay? There is a command for that, and knowing how explicitly CAD and Rhino likes its commands, what do you think that command might be called? Divide.
Divide.
Yeah, if we want to divide something, we're going to type in divide. So I will select this line because I know that's what I want to perform the division on. Type divide. It's going to ask me to select the object again. And now it tells me to enter the number of segments. How many segments do I need? 20. Type in 20, press enter. Okay? Doesn't look like it's done anything. But for example, if I temporarily let's say this line right here, if I put it back on its original layer, and then on my layers tab, if I hide that layer, I can see a bunch of little dots right here. Is that showing up on the projector?
Not really.
Okay. That's okay, because we can still use a snapping mode to make sure that we are selecting each and every one of those divisions. Okay? When the points and the line are the same color, it's going to be hard to snap to what you want to snap to. Okay? But in terms of make small marks along the polyline to make the dividing points visible, what we can do is still on this points layer, I can use a polyline command, and when I hover over my point here, I get a little circle with a cross through it. That's a node snapping point. That's what's going to pop up when I go to snap to that individual point. Okay? And I'm just making a larger polyline so that it's visible. There are little points here, but again, because the colors are similar, it's hard to see. I mean, I can sort of barely see it on my screen. I doubt you can see it here. But you can see that I'm snapping to something. Trust me, there's a point there. Okay? So if I just draw, a little line off to the side here, this will work as my first marker. Okay? And then I'm just going to copy this line and snap to each of these points that show up. Okay? This node, this node, this node, this node, this node. All the way along on each of these 20 divisions. Okay? Here, 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 and there. Okay? So when I turn my contours back on, each of those marks is equidistant based on having 20 divisions of this particular line. Okay? Good so far? Let's go to the next step. Find a second contour line that is 3 intervals lower than the previous one. We're going to call it contour B. Okay? So from this one here, I'm going to count 3. 1, 2, 3. That's my contour B. Okay? And I'm going to do the same thing. I'm going to divide it into 20 equal segments and put marks next to those points so I can see it more clearly. So again, this process is divide. I select the object that I want to divide. Enter the number of segments, 20.
Oh, it's the one.
Here's the other one. Yeah.
Did I do the wrong one?
Yeah.
Yep.
Thank you.
The one just before.
One above it, actually.
Towards the
No.
Up.
towards the lower
1,
left corner.
2, 3. This
There
way.
you go.
Thank you. Okay. And now I can toggle this layer again, just to see with the lights off. Do those points show
Yeah.
up here more clearly?
Yeah.
Then
I hate backseat drivers, but what if we change the point style so the points were a little?
I don't think I've ever done that. How do you do it?
Oops. Well, now I'm front seat driving.